Hey everyone, let's begin. Mr. H teaches the 2019 Mathematics Test, Session 1. All right, let's begin with our first question. Which graph represents a linear function of x? Okay, so I highlighted the words linear function. That's going to be the most important part of our problem. Let's go through the answer choices. A, we can quickly dismiss. Why? Because this is a curve. It's not a straight line. It's not linear. B, we can't dismiss right away. C, we can quickly dismiss for the same reasons as A. It's not even a straight line. And D, we cannot dismiss right away. This leaves us with two answer choices, B and D. We all know that there can't be two answers to a question, especially a multiple choice one. So we have to go back to our original question and reread. Which graph represents a linear function of x? Okay, so if it just said a linear graph or equation, then B and D could both work. But because it says function, one of these is not a function. Can we see which ones? Yes, that's right. It's D because for this input, there are so many outputs. Remember that something is a function when for each input, we have exactly one output. D fails this. So our right answer is B. All right, so we're doing problem number 2, and it asks, what is the value of the expression shown below? Now, this is a division problem with numbers in scientific notation. There's a lot of methods to doing this problem. You could use your calculator, you can convert the numbers into standard form, but I'm just going to show you one of my personal favorites. Well, what I'm going to do first is I'm going to highlight this. When I highlight, that means you should focus in on that, and I'm going to treat that like a division problem, and I'm going to evaluate it. So 1.6 divided by 0.2 is 8. Then I'm going to go on and highlight this part right here, and I'm going to write that down, 10 to the 5 divided by 10 to the 2. Now over here, I'm going to use an exponent law because I have division of exponents where the bases are the same. So I can just subtract the exponents, making my calculation so easy. 5 minus 2 is 3, so 10 to the 3. And now I'm going to put everything together. 8 times 10 to the 3, which means it agrees with B, and that is my final answer. Question 3. At a factory, the cost of making different numbers of toothbrushes is shown in the table below. A linear function models the cost based on the number of toothbrushes made. Which statement about the rate of change of this function is true? So you got to read all of the choices and evaluate, is this true? Is it false? You're going to have 3 false statements and 1 true statement, okay? That's how you do this type of problem. Let's go back and highlight important stuff, okay? So at a factory, the cost of making different numbers of toothbrushes is shown in the table below. We're going to get to the table in a second. A linear function, that might be important, models the cost. So that's going to be your dependent variable. Why? Because your cost is based or depends. They didn't want to use the word depends, but they could have. Depends on the number of toothbrushes made. That is X, okay? That's your independent variable. Which statement about the rate of change? That's important. We've learned all about rate of change this year. And actually, there's another word we like to use. We like to use m, or the word we actually like to use is slope of this function is true. So A, B, C, and D, they're all slope, okay? So we're going to go through A, we're going to go B, C, and D, and we're going to eliminate ones. We're going to classify them as true or false. And if we find truth, then we just pick that one and we go on with it. But if it's not, we have to go to the next one, okay? So how do we do this? Well, we're going to have to use the table and find slope. Slope, remember, is m equals to the change in y divided by the change in x. Change is that little triangle symbol, okay? So now we're going to pick 2 points, and I'm going to pick these 2 points. I'm going to pick 3, and you could pick any 2 points, 3, 450, and 9, 1350, okay? So what I'm going to do first is I'm going to find the change in y, which is 1350 minus 450. And I'm just writing it vertically because I have no real room, okay? You can write it horizontally if you want. So now over here, this is 9, all right? And then we're going to find the change in x. It's going to be 9 minus 3, which is 6. Okay, so now we're just going to do the division problem. M is equal to change in y divided by change in x, which is 9 divided by 6, which is 150 over 1. So our cost increases by 150 for every one toothbrush. Let's go through the choices. The cost increases by 150 for each additional toothbrush made. Hey, I just said that, so that's the answer. All right, so this is how you do this type of problem. Let's go on to number 4. Question 4 is a volume problem. A company makes 2 different sized ice cream cones. The smaller cones are 3.5 inches tall and have a diameter of 3 inches. The larger cones are 5.1 inches tall and have a diameter of 4.5 inches. And it asks about how much greater to the nearest tenth of a cubic inch is the volume, that's how I knew it was volume, of the larger cone than the volume of the smaller cone. One thing I like to do is I like to state my formula and draw pictures. So let's start with number 1, stating the formula. V equals 1/3 pi r squared h. The next part is to draw my pictures. My pictures don't have to be perfect. They just have to organize my thinking. Okay, so I'm going to call that the smaller cone, all right? It has the height, as we can pull apart from the problem, all right, 3.5. I don't have to write my units. I don't have to. I'm just choosing not to right now. And my diameter is going to be 3 inches, okay? Now, I need my larger cone, right? So here, my height is going to be bigger and my diameter is going to be bigger. Okay, my height is going to be 5.1 inches. I'm going to say h equals 5.1. And then my diameter is also larger. D equals 4.5. Now, I know the temptation is to just plug the numbers in, and I'm sure you're going to find an answer that agrees with that. But that is rushing into things, okay? Why can't you just plug numbers in? Because we're given diameter, but the formula tells us radius. So, how do we do this? Well, let's just plug numbers in, and I will leave it there, and I'll let you continue this at home. I'll tell you the answer, and then you'll probably understand after you do it on the calculator how you got that answer, okay? So 3 is to just plug things in. So let's start with the volume of the small cone. It's 1/3 pi. R in this case is going to be 3 divided by 2, or 1.5. We square that. And then h is going to be 3.5, okay? I just took it from my drawing. Volume of the bigger cone is going to be 1/3 pi, and then 4.5 divided by 2 is 2.25. We square that, and we multiply by 5.1. Now, I'm kind of leaving it to you to find the rest. How do you do the rest? Well, you take the volume of the big minus the volume of the small. And you should get a number like this, 18.79 and some change, okay? Well, it asks us to round to the nearest tenth of a cubic inch, so it's going to be A. All right, so I hope that your calculator came in handy there. Let's move on to the next problem. All right, question 7. No, don't rewind. Don't think that I made a mistake. Question 7 is the next question after 4, and you might be wondering, where's 5 and 6? Well, 5 and 6 were not released to us, so we don't know where 5 and 6 are. They might have been field test questions. They might not have been. We don't know. So we're going to go through this question and highlight important key terms, okay? Equation. Which equation represents a function of x that is not linear, okay? So equation is something with an equal sign. We can quickly see that all of these things have equal signs, so that does not help us too much. A function of x is a special relationship that for each x, there's exactly one y. Or put another way, for each input, there's exactly one output. In this case, all these things are functions, so it doesn't really help us. And the last thing, the thing in yellow, the one that helps us the most, is which ones are not linear. So the first thing is I want to talk about what linear means, and then from there we're going to talk about what not linear means, okay? So one way to do this is to think about a linear function, and that one is a straight line, okay? Something like this. Go back to question number 1. It also touches on graphs of linear versus nonlinear functions. Okay, so that's one way to represent a linear function. Number two is to think about what it means to be linear. Linear is all about slope that is constant, okay? And three, the one that's going to help us probably the most here, is all about y equals mx plus b. So these are all examples of linear functions. Now, what is not linear? Well, let's go through all of these and let's just put not linear in red, okay? So over here, this is not linear. So it's still a function, but it's not linear, okay? A slope that is, in this case, it's pretty easy, not constant. And number three, also pretty easy, it's just something that doesn't fit this form, okay? So we're gonna look through each choice and we're gonna see what doesn't fit the form. All right, A, y equals 4x plus 12. Whenever I see parentheses, I have to distribute. Now, A fits the form, right? Because we can rewrite it as y equals 4x plus 12 as we did. And you can quickly see that this is the slope, this is the y-intercept, and you're done. So A is linear. B looks not linear at first, but just evaluate 4 squared. That's 16 plus 3x. Now, it doesn't matter that it's in a different form. It's still y equals mx plus b. So B's out. C and D. Most students are going to pick D. Why? They see a division problem, they go, must be it. This is the only one that's division, so it has to be it. But it kind of tricked you, okay? So we're going to look at D first. So D is going to be y equals, I'm going to do the division here. So 4 over 3 plus x over 3. And I'm just going to change the way it looks. 1/3 x plus 4/3. You might be saying, oh my gosh, that's linear. It fits the form y equals mx plus b. Exactly, they were banking on tricking you with that. So D is linear as well. C is not linear. Why? Because of this exponent. Whenever we have an exponent here and it's on the variable, remember B had an exponent on the number, when the exponent's on the variable, then it's automatically not linear. Our choice is C. Okay, let's move on to the next problem. Number 8, which equation represents the line shown on the coordinate plane? So we have a line here, and let's just view the line and make some impressions real quick, okay? First impression is passes through origin, okay? Second impression, and maybe these two could be interswitched. Maybe you notice this one first, it's fine. This is linear. Now, they tell us it's a line, so linear. It's also an observation if you read the problem, but passes through the origin and it's linear. Right away, we should know that this is proportional. This is proportional. And 3, it has a negative slope, okay? So how do we know it's negative? Well, let's look at the line, read it from left to right, and you can see that the line is going down, okay? So it has a negative slope. And we need to find that slope. There's a couple ways of doing it. I'm going to do it one way, and you could do it any way you want. The way I'm going to do it is I'm going to find m equals rise over run, okay? So I'm going to find 2 points and find the rise and find the run, okay? So I'm going to choose this point and I'm going to choose this point. So the rise is going to be going down 2 boxes, but also 2 units. You want to make sure your scale agrees with your boxes. If it doesn't, adjust accordingly. So going down 2, that's my rise. And my run, I'm just going to make it in a different color, just so it's easier for you guys, is 1, 2, 3, 4, 5, 6, 7, 8. So it's divided by 8, but it's positive 8 because I'm going to the right. So now all I have to do is simplify and put it into y equals kx. Why kx? Why not y equals mx plus b? You could also use y equals mx plus b, but I'm taking advantage of the fact that this is proportional. So I'm going to say y equals kx. Okay, so I need my k or my slope. And by the way, I wrote m, but I could have also written k. Same thing when it's proportional. All right, so in this case, we're going to simplify negative 2/8 into negative 1/4 x, and I'm going to eliminate a. I'm going to eliminate c right away because those are positive slopes or positive constants of proportionality. They're gone. B and D, I can eliminate B because it's negative 4, and D is my final answer. All right, let's move on to the next problem. Number 9. The closest distance between Earth and Mars is approximately 3.39 times 10 to the 7 miles. The fastest rocket leaving Earth travels at an average speed of approximately 3.6 times 10 to the 4 miles per hour. At that rate, which expression could be used to determine the approximate number of hours it would take for the rocket to travel that distance? So here are a couple of things. First, I love to draw pictures, so I'm just going to draw Earth. Okay, it's not the best picture of Earth. It's pretty good. You know what? It's amazing. And now this is Mars. It's a little bit smaller than Earth, I guess, so my picture shows that. And now I'm going to write the distance right underneath. Okay, this time I'm going to use the units because it might be important. And now there's this rocket. Okay, let's see if I can draw a rocket. Probably not, but that's not bad, okay? It's my rocket, and it travels, so my rate is 3.6 times 10 to the 4 miles per hour. And I want to find how long, or the approximate number of hours it would take for the rocket to travel that distance, okay? So what I need to do is recall a formula that I learned as early as 6th grade, maybe even earlier than that. Distance equals rate times time. Some people remember it as dirt. That's fine. So now we need to find the time. The time is going to be distance divided by rate. So I'm going to be dividing here. I'm going to be dividing the distance, 3.39 times 10 to the 7 miles, divided by 3.6 times 10 to the 4 miles per hour. That's another way of writing miles per hour. And here I don't need to evaluate. I love this problem. I don't need to evaluate. So I'm going to stick with just finding the expression that closely resembles what I have. Well, A and B are out. Why? Because of that minus sign. This is not subtraction. This is division. So C is the answer, but D is not the answer because they flipped around numerator and denominator. That's gone. Bye-bye. So the answer that makes the most sense, that helps us find the rate, helps us find the time because we know the rate, is C. All right, question 11. Triangle A and triangle B are graphed on the coordinate plane below. Which sequence of transformations will map triangle A onto its congruent image, triangle B? So again, this type of problem I don't really like too much because we have to go through the choices and eliminate eliminate all the false ones, and once we find the true one, we're done, okay? So a reflection over the x-axis and then a reflection over the y-axis. Okay, so let's start by having a reflection over the x-axis. Our triangle is going to end up here. All right, and then once we have a reflection over the y-axis, I'm going to put this in a different color so you guys can see. Our triangle is going to end up here, but it's going to be the wrong direction. So A is out. All right, A cannot be right. So I'm going to restart everything. I'm going to erase everything and go with B. Okay. All right, so B says a translation of 8 units down and then a reflection over the y-axis. All right, 8 units down. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then I'm going to take the rest of the triangle here. All right, so I'm going to have this triangle. And now a reflection over the y-axis. Now it's going to look something like this. Still not exactly what we want. So B is gone. Now we have to go to C. Do you see why I don't like these problems? Okay, it's great if the answer is A, but if it's not, you have to go through all of them. Okay, a reflection over the x-axis, and then a translation of 6 units to the left. All right, so let's try that. We're going to go down here. It's going to look like this. Okay, and now 6 units to the left. 1, 2, 3, 4, 5, 6. So that's where that point's going to be, and the rest are going to be right on top of triangle B. So C is the answer, okay? Let's go on to the next one. All right, number 12, which system of equations has no solution? All right, so just to recap, a system of equations is 2 or more equations, and when it doesn't have any solution, right, it looks like this. AX plus BY equals C, and AX again plus BY again equals D. So just taking this apart, A and A, the coefficient of X, they're going to agree. B and B, the coefficient of Y, they're going to agree. But the stuff that doesn't agree is the C and the D. Okay, so when you have that, it actually, if we were to graph it, it looks like 2 parallel lines, okay? So the slopes are the same, y-intercepts are different. And you can go through all A, B, C, and D, and you can see which ones follow that A, the coefficient of X agreeing, coefficient of Y agreeing, but the constants don't agreeing, and the answer is B. Let's just kind of analyze why that's the answer, and then we're going to look at A and see why that's not the answer, and then you could do C and D yourself, okay? So the reason why B is the answer is because we have this. 7x minus 2y equals 9, and 7x minus 2y equals 13. Again, we have 7 agreeing with 7, just like we wanted. Negative 2 agreeing with negative 2, just like we wanted. But the 9, there's no way that 9 is equal to 13. No way. So B is the right answer. Let's look at A, and you might think, hey, that one we could just skip, right? They're not the same at all. But the 3x plus 4y, let me just write that down. 3x plus 4y equals 5. Well, we can change that. We can change that by multiplying everything in this by 2. And then what we'll get is 6x plus 4y equals 10. And then writing this right here, let me just, right here, 6x plus 4y equals 10. They're the same exact equation. When you have the same exact equation, you have infinitely many solutions. So if this problem asked for infinitely many solutions, A would be an answer, and spoiler alert, so would C. D only has one solution, and I invite you guys to check that. Okay, let's go on to the next problem. 13, a line is graphed on the coordinate plane below. As we can see, the line y equals negative x plus 2 will be graphed on the same coordinate plane to create a system of equations. Hey, just like we just finished. What is the solution to that system of equations? Now, when you're graphing a system of linear equations or a system of linear and nonlinear equations, you're looking for an intersection point, okay? So for example, let's say I graph this line, then I graph that line, okay? The intersection point here is the solution to that system of equations. So over here, they're looking for an answer, but they didn't give us the second line graph. They want us to graph it. So let's do that. We're going to start at 2, and the slope is going to be negative 1. So it's going to look like this. Oops, I made a mistake. Maybe you saw that, maybe you didn't. And I'm just continuing with the pattern, and I want to connect this as straight a line as possible. I don't have a ruler on this device, but you probably will on the test. No, you definitely will. So you always want to take advantage of the tools you are given. So here we have an intersection point. It's right here. But the question is, where is that intersection point? Well, we always put the x first. It's going from the origin 1, 2, 3, 4, and then down 2. So it's 4 minus 2, and we have D as our answer. Let's go on to the next one. 16. Rectangle A prime, B prime, C prime, D prime is similar to rectangle ABCD as shown on the coordinate plane below. Which sequence of transformations maps rectangle ABCD onto rectangle A prime, B prime, C prime, D prime? Couple of things to note here. Okay, whenever we have prime symbols in the letters, that's the image. okay? And whenever we have no prime symbols, you can quickly know that that's the preimage. The difference between the image and the image is the figure after the transformation. The preimage is the figure before the transformation. Another word that's important here is the word similar. Similar tells us that a dilation has occurred. A dilation changes the size but not the shape of the object. So the first thing I want to do is I want to find the scale factor, okay? So the scale factor is going to be the length of b prime a prime, which is 2, dividing that by the length of ab, which is 4. So 2 divided by 4 is 1/2. So the scale factor in this case is going to be 1/2, okay? So that's going to be important. Actually, you could have just known that just by looking at all the choice options. They're all scale factor of 1/2, but knowing how they got that's important too, okay? So now what we want to do is we want to pick any coordinate, okay? So I'm going to pick C. Why? I don't know. I just like C. C is 6, 2. C prime is going to be half of 6, which is 3, and half of 2, which is 1. So C prime is going to be 3, 1 right here, 3, 1, right? And you can map the others, okay? So it's going to be something like this. This is C. This is going to be D. This is going to be B. This is going to be A. You can call them primes. That's okay. Just know that this is another sequence is going to happen. So it's not really prime yet, okay? And now I want you to focus your attention on the way the letterings are oriented. If we start from A prime and we go clockwise, the way a clock moves, A prime, B prime, C prime, D prime, okay? So now if you look at A and you go clockwise on the image, the one right here, it's A prime, D prime, C prime, B prime. It's not in the same orientation. So that gives me a clue. That tells me that a reflection has to have happened, okay? So that tells me that it's going to be a scale factor and then a reflection. So the only one that fits both of those sequences, this tells you a translation has occurred. No way, Jose. B is a reflection across the y-axis and then a scale factor. It doesn't matter the order in which you do these things. I mean, sometimes it does, but in this case it doesn't. C is a rotation and D is also a rotation. You can spend a lot of time on this problem and you can clearly, you can see more clearly how C and D just don't make much sense. But I think the way I did it, where you're looking at the way the points are kind of oriented, that really helps you understand that a reflection has occurred. 16 is a bit tricky, so take your time with it, try it again. There are other ways to solve it, and I can make a video just on 16 alone. If you want, let me know in the comments below. Okay, question 17. I love this problem. I don't know why. Maybe it's because I'm about to draw a really cool picture, so I'm excited, but I love this problem. Patty has a flower box in the shape of a rectangular prism with interior dimensions that are 15 inches in length, 8 inches in width, and 6 inches in height. Patty will fill the flower box 3/4 full of soil. How many cubic inches of soil will be in the flower box? Okay, so I like to draw. Let's draw this. Okay, so this is my version of the flower box. So maybe let's just draw like a flower. I just love drawing. I don't know why. Let's draw a different color flower this time. Yeah, blue. Who doesn't like blue flowers? I don't know. I love blue flowers. Do blue flowers exist? I mean, they have to, right? They're pretty rare, so I don't see them. Anyway, let's go back to the math problem. So here it says 15 inches in length. So we're going to call this 15 inches. The width is going to be 8 inches. Let's just give them units. Why not? Okay, and the height is going to be 6 inches. Now, this is a rectangular prism. That's why we drew it like the way we did, like a tissue box, okay? And here's the thing. If we just multiply all three of these numbers, we're not going to get the right answer. Why? Because this person is filling this with soil about 3/4 of the way full. Okay, so that's my best kind of guesstimation as 3/4. So what we're going to do is we're going to take the volume, which is going to be 3/4 because it's 3/4 full. Let's just underline that, times 6, 8, and 15. Okay, so 3/4, I mean, we can go through this if we want. What I'm going to do is I'm going to take 8 divided by 4, multiply by 3. So we get 6 times 6 times 15. 6 times 6 is 36. 36 times 15. I'm going to do something very popular, and I'm going to leave it up to you. Nah, let's do it together. Why not? I don't have a calculator handy, and I'm kind of bored anyway, so let's just do it. 30 times 15 plus 6 times 15. What did I do? I broke 36 up into 30 and 6. 30 times 15, 3 times 15 is 45, times 10 is 450. So our number has to be at least bigger than 450. So A is out. And 6 times 15 is going to be 90. Why did I write an equal sign? I don't know. Let's get rid of that. Okay, so I'm going to take 450 plus 90, and that's going to be 540. So the volume of the soil is going to be 540. And I really wish they would have written the units here. So it's going to be inches cubed. Yeah, inches cubed. Okay, told you I love this problem. Isn't it cool? Problem 24. Which statement best describes the data in a scatter plot where the y values are decreasing as the x values are increasing? So a lot of vocabulary here. Data is just a group of points. It's just points, x point, y point. Scatter plot, we're going to talk about that in a second. Let's actually talk about that now. Let's make a graph. And a scatter plot is just a scattering of data points. Okay? So that's a scatter plot. Just write that there. All right, so they want to know, what does a scatter plot look like, all right, when we increase the y, or I'm sorry, when we increase the x, the y is decreasing. So as we go to the right, the y is going down. So it looks like this. And I know I'm not doing the best job, but it should be all data points, okay? So A says the data can be best the data can best be modeled by a vertical line. No way. The data can best be modeled by a horizontal line. A vertical line is up and down, straight. Horizontal line is left to right, straight. No. And the data can best be modeled by a line with positive slope that looks like this. And that, again, is a no. The data can best be modeled by a line with negative slope. Absolutely. Let's just look at why. If I put a negative slope line, it fits my data the best, okay? The others just don't fit the data that well. They do fit the data, but just not in the best way. All of these words kind of have, or all of these options have the word best in it. So all of them work, but D works the best, okay? All right, 25, another really good problem. Which proportional relationship has the greatest rate of change? Proportional relationship, we already talked about this, but it's a line, and it passes through the origin 0, 0, the point 0, 0. Okay, has the greatest rate of change. They're talking about the slope, or in this case, they're going to be talking about k, the constant of proportionality. They're the same thing. Okay, so A, right away, k equals m. They're the same thing. I'm going to be writing m. M equals 7. How do I know? It's right there. It's so easy. Okay, so C, I'm going to go to C. I'm going to skip B for now. C is we need to kind of find the slope. So remember, slope is change in y divided by change in x. All right, so this is plus 2. This is plus 8. So M equals plus 8 divided by plus 2, which is just 4. Already A is winning because in this case M equals 4. So bye-bye, C is gone. B, it says the value of y increases by 12 for every increase of 4 in the value of x. So what they're saying is the change in y is 12 and the change in x is 4. So M is change in Y, which is 12, or I'll just write it like this, change in Y over change in X equals 12 over 4, which is 3. So right now, A still winning, B is gone. And the last one is a graph, okay? So the last one I'm just going to do in a different color because I want to get 2 points. I'm going to find the slope by getting the run. In this case, there are 4 units here. And then just a different color for you guys. 1, 2, 3, 4, 5, 6. There are 6 boxes, but remember each box is counted by 2. 6 to 8 is 2, 8 to 10 is 2, etc. So that's 12, okay? So M is equal to 12 over 4, which is, again, not again, but is 3. Okay, so which one is the winner? A. A is the winner. A has the highest slope, which means it has the greatest rate of change. 29. Which expression is equivalent just means equal to 5 to the negative 2 to the power of 5 times 5 to the power of 4. So here we just make use of laws of exponents. Now you can also just plug this all into your calculator and compare everyone, but I think that's not really what the problem is asking you to do. So let's do it this way, okay? 5 to the negative 2 to the power of 5. Well, using our exponent properties, we're just going to multiply negative 2 times 5. And then at the end, we're going to multiply everything by 5 to the 4. So here, negative 2 times 5 is 5 to the negative 10 times 5 to the 4. And now what we do is, because we're multiplying, we're going to be adding negative 10 plus 4, which is 5 to the negative 6. And we don't see 5 to the negative 6, so we must have made a mistake. Nope. Relax, don't panic. Okay, so 5 to the negative 6 can actually be written as a fraction, 1 over 5 to the 6. And hey, that's C. So that's how we do that one. 30, and we're almost done. Linear functions M and P are shown below. In comparing the rates of change, which statement about function M and function P is true? Okay, so they're talking about rates of change. We need to find the rates of change of function M and function P. And spoiler, function P, really easy to do. Let's find function M first. Okay, so how do we do function M? Well, all we have to do is just find the change in X and find the change in Y. M is equal to the change in Y divided by the change in X. So M is equal to positive 10 or plus 10 divided by positive 2 or plus 2, which is just 5. So if I were to write this, I can say M equals 5 right up here. And function P, so quick, it's right there for you, okay? So M is equal to 7. How did I get that? Well, remember that Y equals MX plus B. And this, the Y's are there, the MX is right there, and the B is right there, okay? So M is 7. That's how I did that. If you just want a little bit more detail, okay, I'll just write it right down here, 7x plus 9, and you can very quickly see that M is 7. Make sure the y's agree, okay? So if the y's don't agree, you have to make sure that the y's agree. So in this case, you kind of have it easy because the y's are the same. Now we have to go through the choices. Their rates of change differ by 2. That's the right answer. 7 minus 5 is equal to 2. Their rates of change differ by 4. I'm just going to go and show you why this is not true. 7 minus 5 is not equal to 4, so this is done. Function M has a greater rate of change than function P. Is that true? Is 5 bigger than 7? Absolutely not. It's not true. And function M and function P have the same rate of change. Are they equal? Absolutely not. They're not equal. So A is the right answer. B, C, and D are all incorrect. "31 is the scatter plot shows the average number of customers who visit a food truck per day depending on the number of days the food truck stays in the same location. Okay, which statement best describes the association between the number of days the food truck stays is in the same location, and the number of customers who visit the food truck per day. So there are 4 choices. There's no association. There's a nonlinear association. There's a positive linear association. There's a negative linear association. So now over here, what we're going to do is I just want to show you what each of them looks like, okay? And we're going to match it to what we see on the table. So A looks like this. If you have one quadrant like that, I'm going to do a different color. No association. The points kind of look really random, okay? They look like there's no real relationship here, okay? Maybe random's not the best word, but there's no pattern that can be deduced, all right? So that's what no association looks like. Well, we can eliminate A right away because they don't match at all. So let's look at B. B is a nonlinear association. So it looks like this. Now you can have different types of nonlinear associations. So I'm just going to show you one. So at first it looks like a positive association, but then it kind of comes down, right? So that's a nonlinear association. And we can see that our table doesn't have that. All right, so C is a positive linear association, right? Now that one looks like this. All right, let's go back. Let's cancel B. And let's look at C and see that C really looks like what our food truck customers graph looks like. So C is the right answer. I'm going to give that the green circle. And D, I just want to show you for, education's sake, what this looks like, a negative linear association. If you can deduce, that's great, but if you can't, it looks like this. You can see the data is kind of going down, right? So the data is going down. So that's what all 4 graphs sort of look like. I mean, there's different variations of B, the nonlinear, but right here, this is the best I can do in this page. D is not the answer. C is the answer. Okay, let's go on to the next question. Okay, hands down, my favorite question on session 1 is this one. 32, the measures of the angles in triangle UVW are shown in the diagram below. What is the value of X? Now, why is this my favorite? It blends 2 types of knowledge, the geometrical knowledge of triangles and the algebraic knowledge of how to solve for an unknown variable. So let's see what we can do. This is an angle, this is an angle, and this is an angle. We know there are 3 angles in a triangle. I just found all 3. What are they equal to if I take their sum? Well, a triangle has 180 degrees in its interior, okay? So what that means is if I take all 3 angles, I don't know what each angle is, but I know that each angle, when I sum them all together, that has to equal 180. So that's the geometric knowledge that you have to use, okay? You have to know that this, when I take all of them and I add them up, it's equal to 180. The next bit of knowledge is solving for that pesky X, okay? What is that X? Now, we could do this in a variety of ways. One way is to just plug A in, plug B in, plug C in, plug D in, and see which one works. That's not the best way. It works, but, there are better ways. So let's look at one of the other ways right now, okay? So what I'm going to do is I'm going to combine like terms, right? Negative 9 plus 30 is 21. 21 plus 24 is going to be 45, and it's positive, okay? So now we have this. And now what do I want to do? I have 3x plus 45. I want to do the opposite of adding 45, which is subtracting 45. Whatever I do to one side, I have to do to the other to keep the equation balanced. So now I have 3x plus 0. We got rid of that. That was the whole point of that. Equals 180 minus 45 is 135. And I'm going to undo multiplication with division. They undo each other, and I have x equals, finally, I have x equals what? X equals 45. So that is C. Okay? This is my favorite problem. And again, just to summarize, why is it my favorite? It combines two things, geometry and algebra, and it does so seamlessly, and I just love it, okay? Be aware that I answered this question. I said, what is the value of x? I gave it an answer. Now, it could have asked me, what's the measure of angle U? So if it asks me what's the measure of angle U, 45 couldn't be the answer, okay? We would have to plug in the 45 right here into x, and we would find that, okay? But in this case, I'm going to just exit out of there just because I don't want to confuse you. I love this problem. I hope you do too. 33. The graph of a function is shown on the coordinate plane below. Which statement correctly describes the function on a given interval? So A, it says the function is decreasing and nonlinear between -7 and -4. So let's look at -7 and -4. Okay, I'm just going to highlight that in green, and that does not look like it's decreasing. It's definitely nonlinear. So I'm going to give the nonlinear part a check, but the decreasing part an X. So both parts have to agree. That's gone. Bye-bye. So now, B, the function is increasing and linear between -4 and 1. No, it's not increasing. It is linear, so I'm going to give that part a check. But increasing? No way. It's no change. Slope is 0. Okay? Stop trying to trick me, problem. I'm on to you. So C, the function is increasing and linear between x equals 1 and x equals 4. So it's going to be over here. And now you might be tempted to say yes. Why? Because it's definitely increasing. But is it linear? It's close to being linear. But remember, in mathematics, it's not about being close. It's about being precise, exact. So it's not linear. That is a curve. That's gone. That's out of there. And finally, the last one. It's decreasing and nonlinear between x equals 4 and x equals 11. And by process of elimination, that's the right answer. But let's see why. It's definitely decreasing. It's going down. And it's definitely nonlinear. It's not a straight line. It's a curve. So D is the right answer. And whew, that concludes session 1 from the Math State Exam, from the New York Math State Exam of 2019. Thank you so much for making it to the end with me. I really appreciate it. I write down in the comments below if you really enjoyed this video. If not, let me know how I can make it better. I'm happy to hear all feedback. See you next video. Ciao.